The normal calcium range within the blood is 8.5 to 10.5 milligrams per deciliter. Now remember, most of the calcium in the body is in the bones. So what we're talking about now is the free sodium in the plasma. Calcium also has a neuromuscular reactions. It increases neuronal excitability, and it stimulates muscle contractions. And again, it's in the skeleton, the smooth muscles, and the cardiac muscle. If someone is suffering from hypocalcemia, they're likely to have numbness and tingling, muscle cramps and spasms, an increase in their deep tendon reflexes. They may have tetany, which is persistent muscle spasm, and they may have a drop in their blood pressure. If someone has hypercalcemia, their kidneys are not able to concentrate urine. Therefore, we're going to see polyuria. That means they're going to the bathroom and urinating all the time, and therefore they're thirsty. They're having some renal insufficiency. Their kidneys just aren't working right, and we might see some kidney stones. We'll see weakness and a drop in muscle tone, lethargy and coma if it persists. Blood pressure actually goes up, and there's anorexia, nausea, vomiting, and constipation. Magnesium. The normal range is 1.8 to 2.7 milligrams per deciliter. And when we think about magnesium, think about neuromuscular functioning. If there's too little magnesium in the blood, we're going to have neuromuscular excitability. We'll have tremors, an increase in the deep tendon reflexes, heart rate and blood pressure go up, and we might see cardiac arrhythmias. However, if there is too much magnesium in the system, we're thinking neuromuscular depression. Now this is rare except when the kidneys aren't functioning, because magnesium is excreted through the kidneys. So in a normal person, unless we're giving them magnesium to treat another condition, hypermagnesemia is rare. We would see lower neuromuscular transmission. We'll see lower deep tendon reflexes. They'll be weak. They'll be confused. We have a drop in blood pressure. If it gets really bad, we're going to see a drop in respirations as well, and we may be moving towards coma. Acid-base balance. Now I'm going to refer you to another site to do much of your studying on acid-base balance, but let's just talk about a few things first. Normal pH is 7.35 to 7.45, and the HCO3 is 22 to 26 milliequivalents per liter. I like this diagram. If you haven't guessed, I like diagrams. I find it easy to follow along when I see them. Well, this slide shows you how acidosis and alkalosis and metabolic and respiratory all fit together. Along the bottom of the diagram is pH. We see that normal pH is 7.35 to 7.45. Along the left side is HCO3, which is bicarbonate, and bicarbonate is a base. Along the top is PaCO2, which is a way of measuring carbon dioxide, and carbon dioxide is acidic. Let's start with the upper left box. In that one, we can see the pH is low. That means it's acidic. And there is a rise in the carbon dioxide, the PaCO2, which is acidic. That makes sense. More carbon dioxide, more acidic. How do we get that way? Well, we get that way primarily by not blowing off carbon dioxide. We've got a state of hypoventilation. For some reason, the person is not breathing enough and carbon dioxide is being retained. Now let's follow that diagonal line down to the right bottom box, And this is the opposite. This is hyperventilation. The person is blowing away too much of the carbon dioxide, so there's not enough. So there's a state of alkalosis. Looking at the metabolic diagonal here, we can start in the bottom left. Low pH, acidosis. Low bicarbonate, that means not enough of the base. So we've got metabolic acidosis. How do we get that? Well, one of the ways you're going to learn more about is diabetic ketoacidosis. We get it from renal disease, and we can also get it from diarrhea. At the top right is metabolic alkalosis. We can get that by losing acid. One of the big ways we do that is through vomiting. That's one of the common ways. People end up in metabolic alkalosis. They're vomiting out the stomach secretions, the stomach acid. Okay, well, the body cannot survive for a long period of time outside the range of normal pH. So the body tries to compensate. It does that through respiratory means. Well, let's increase or decrease our breathing to help change the acid pattern. So you're going to see with the metabolic alkalosis and acidosis, you're going to see changes in the PaCO2. In the metabolic acidosis, you're going to have a drop in the PaCO2, and the metabolic alkalosis, you're going to see an increase in it. With the respiratory acidosis and alkalosis, the bicarbonate comes into play as a compensatory mechanism. Either it goes up or it goes down, trying to change the pH of the system. There is another assignment for you to do, another website for you to go to, which is going to go into more detail.